Evgenia, you can start.
Okay, thank you very much. We are starting. So, good morning, dear participants, organizers, and guests of this international conference. I'm glad to be part of this event, and my name is Evgenia Basova. I'm an associate professor at the National Technical University Kharkiv Polytechnic Institute, and today I'm pleasure to present the work of 9th section of the international conference, InterPartner-2024. Our section entitled Research in the Field of Mechanical Engineering. Its section will be include 7 presentations and little bit about each of them. The first presentation focused on a study entitled Design of a Helical Shredding Drum Blade and Determination of its Unfolding. This study involved scientists from the National University of Life and Environment Science of Ukraine and Sumy National Agrarium University, also Sumy. The next presentations following report is on contact interaction of a bell with a toroidal running track with closely shaped. This work was carried out by researchers from one of the oldest university in Ukraine, National Technical University Kharkiv Polytechnic Institute. Next presentation, the titled paper is developed to the topic modeling dynamic response and stability of the combined mechanical system with 2 degrees of freedom. This work is international and was carried out jointly by researchers from the Academy of Professional Study, Sumaji, Serbia, Donbas State Engineer Academy, Ukraine, and Engineering Academy of Serbia. Next, force of our attention will be presented a paper entitled A Fundamental Solution of the Dynamic of Twin isotropic plates laying on an elastic base. This work has an interesting creative team from Vasil Stus Donetsk National University, Ukraine, and University of Connecticut, USA. I personally think that the work deserves special attention, as well as other work of our section. Among other papers, a paper entitled Superconductivity. Next presentation, superconductivity of a friction pair of brake devices in planet to be, and I think it's will be also very interesting. This work will be presented by an interdisciplinary team from Ivano-Frankivsk National Technical University of Oil and Gas, Ukraine, Nadvirnya, Vocation College of the National Transport University and Lviv Polytechnic National University, also Ukraine. The sixth paper of our section will be devoted to superconductivity of metal friction elements of brakes. This work will be presented by a team of researchers from Ukraine, Odessa Polytechnic National University, Lviv Polytechnic National University, Drohobych Applied College of Oil and Gas, and Odessa Automobile and Road Vocational College, Odessa Polytechnic National University. And the final paper of our section will be a report by Maxim Stoda on his personal research on stress and strain state of a bar in the space between the stand of a continuous shape rolling mill. In this paper, Dr. Maxim represents the area of interest of Technical University, Metinvest Polytechnic. So I think our section will be very interesting. I hope all of you will have good opinions and will come to us to share your opinion and to have a discuss. And now I wish good luck to all participants, and we are starting.
Dear participants, your attention is invited to a report of design of a helical shredding drum blade and determination of its unfolding. To manufacture a helical knife, it is necessary to have a mathematical description of its surface, including geometrical dimensions and angles. The shape of the helical knife is directly linked to the contour of the flat blank. With significant plastic deformations of the blank during its transformation into a helical surface, it is impossible to determine its exact dimensions. As a prediction, the metal displacement during the deformation of this blank is not feasible. However, certain parameters, such as line length, are not prone to significant distortion. Consequently, it is possible to find theoretical contours of the blank that will allow determining the final contours experimentally. This expedites the experimental search, underscoring the relevance of the research. Based on the above, the aim of this study is to analytically describe the surface of a helical knife and construct its approximate unfolding based on the given geometric parameters. According to the given geometrical parameters, describe analytically the surface of the helical knife and construct its approximate sweep. The cutting edge of the helical knife is a helical line that convexly lies on the surface of a cylinder with a radius r and has a constant inclination angle tau related to the horizontally positioned cutting blade, figure 1. The cross-section of the knife is a straight segment inclined at an angle phi to the radial direction, figure 1b. Decreasing the angle phi deteriorates the cutting process, but its increase also has limitations. With the drum rotation uniformly, a layer of plane mass with thickness h moves with a constant speed v in the direction of the knife, figure 1c. Cutting of the layer starts at the top and ends near the cutting plate. As the layer is cut not simultaneously throughout its thickness, but gradually, the profile of the cut layer will be outlined in the form of an archimedial spiral, figure 1c, where it is shown inside a circle with radius r. Considering the thickness and sharpness of the knife, it should not touch the spiral. Otherwise, displacement of the blunt mass will occur. This factor determines the limiting value of the angle phi. From a geometric standpoint, the surface of the knife is a straight open helicoid. It is a ruled surface where the guiding cover is helical line, the edge of the blade. Through every point on the blade, this passes a straight generation line that is tangential to the helical line axis, forms a right angle with it, and maintains a constant angle phi with the radial direction, as shown in figure 1b. Let's express the parametric equations of the helical line, which is the angle of the blade, and describe a cylinder with radius r during the rotation of the drum, equations 1, where b is the helical parameter, a constant that determines the value of the angle tau, figure 1a. Alpha is an independent variable with physical significance, representing the angle of rotation of a point moving along a helical path around its axis. The helical parameter b is determined from the formula 2. By substitution 2 into 1, the parametric equations of the helical line with the specified values of r and tau can be obtained. When varying the angle alpha from 0 to 360 degree, obtain one pitch of the helical line. In our case, the limiting value of the angle alpha with the smaller as the helical line is constrained by the length L of the drum, region 1A. We will find it by substitution L for x in the first equation 1, considering the expressions for B from 2. The directional cosines of the straight geometrics of the helicoid forming an angle phi with the radial directions, figure 1b, are expressed as follows. Equations for the parametric equations of the helicoid surface, considering the expressions 2, 1, and 4, are given by equations 5, where u is the second independent variable representing the length of the straight geometrics measured from a point on the helical line. In order to ensure a constant load on the cutting drum, it is necessary to maintain conscious cutting. After completing the cutting with one blade, after rotating the drum by angle alpha 3, cutting immediately commences with the next blade. Based on this, the number of blades n can be determined with the following equation. Given the specified radius r of the drum and the angular parameter tau, which is part of the expression 3, as well as the accepted number of blades n, we can find the length L of the drum, equation 6. To manufacture an individual blade, a flat blank is required. Its contours should be such that plastic deformation are minimal when the blank is deformed into the final product. To find it, we assume that the length S of the outer edge of the blade length, and the length of the inner edge S, as well as the width of the blade U0 on the flat blank are equal to the corresponding dimensions of the helicoidal blade. Its length is found using a known formula 7. The length of the inner edge of the blade can also be determined if the radius r of the inner circle is known, figure 3a. The radius r is a side of a right angle triangle defined by two other known sides r and u0 and the known angle phi between them, figure 3a, equation 8. The length of the arc corresponding to the inner edge of the blade is found by multiplying the radius r by the corresponding arc angle alpha 0, formula 3. The length of the helical line can be determined as the hypotenuse of a right angle triangle, where one leg is the length of the arc on the cylinder of radius r, and the other is its length L. After appropriate operations and transformation, we find the length S of the inner edge of the helicoidal blade, formula 9. In figure 2, we can see helicoidal blades of 0 thickness constructed using equations 5. A. Representation of an individual blade. B. Blades uniformly rotated around the drum axis. When tau is 0, the length of both edges according to 7 and 9 will be equal to the length L of the drum. This is irradiant because helical lines transform into straight lines and the helicoidal blade becomes a flat blade with a straight edge. Expressions 9 can also be divided using the left side of the formula 7. If in the equations 5 substitute a constant value for the blade with u0 instead of the variable u, they will describe a helical line, the inner edge of the blade. Its length can be found by integration the expression 7. Substituting into it the derivatives of the obtained equations for the inner edge, the result will be analogous to formula 9. The lengths S big and S small of the helicoidal blade edges are different in magnitude because they are located on cylinders of different radii. The length S0 of the arc of the outer edge of the flat ring corresponding to the length of the blade of the helicoidal blade is found using the known formula 10. The expressions to determine the length S0 of the corresponding arc are formula 11. In figure 3, you can see graphic illustration for the calculation of a flat blank for the helicoidal blade. A. Schematic of the blade on the drum with indication of its parameters. B. Flat blank of the blade with indication of the necessary dimensions. By equating the lengths 7 and 10 as well as 9 and 11, we obtain a system of two equations with the unknown r, 0 and c. Solving the system for these unknowns, we get formula 12 and 13. For this purpose, parametrical equations 5 for a direct open helicoid were initially developed, incorporating the design parameters of the blade and define the limits of the independent variables considering the determinants of the blade. Formula 6 allows the determination of the drum's length based on the number of blades, drum radius, and the angle of inclination of the helical line cutting edge to the drum axis. To determine the shape of the flat blank, the assumption was made that the length of lines outlining the contour of the blade in space and the corresponding lines on the flat blank are equal. Figure 3 clarified the algorithm for finding these lines on the surface of the blade. The length of the external helical line of the blade is determined by formula 7, and the length of the internal one is determined by formula 9. On the surface of the blade, the external and internal helical lines correspond then to arcs of circles on the flat blank. The radius of the arc of the external circle is determined by formula 12, and the central angle of which it is based is determined by formula 13. A helicoidal blade with a resicular transverse section is non-developable surface, meaning it does not have an exact unfolding. Therefore, it is necessary to find the contours of the flat blank in the form of an approximate unfolding. The flat blank was determined based on the condition of minimizing plastic deformations during the shaping of the final product. For this purpose, the assumption was made that the length of the helical lines that bound the blade externally and internally should be equal to the corresponding lines on the flat blank. The width of the blade also remains constant. Based on this, a flat blank in the form of a ring was found, the dimensions of which are determined by the geometrical parameters of the helicoidal blade. Thank you for your attention.
This contribution is delivered to you by the Chair for Theory and Computer-Aided Designs of Mechanisms and Machines at Kharkiv Polytechnic Institute. The radial hydrovolumetric transmissions can be designed to be compact, powerful, and durable, and thus are suitable as an integral part of vehicle powertrains. One of the bottlenecks of this design is the transmission of force between the ball pistons and the stator ring. The rational choice of the profile requires the analysis of contact interaction for various geometries of the running track. The aim is to adapt a numerical model developed in previous works based on a variational formulation, incorporation of various physical factors, numerical implementation in the form of finite and boundary element models, to the analysis of the elements of radial hydrovolumetric transmissions providing parametric solutions of the problem of contact interaction of bodies of complex shape. A variational approach is applied to the analysis of contact interaction of bodies of complex shape based on minimization of either the potential energy or the complementary energy. The quadratic terms need to be added in order to account for the local deformations of the intermediate surface layers. The particular shape of the profile is defined by a power function chosen in the present analysis. The dimensionless parameters of the profile geometry are varied in the span for the radius between 0 and 1, and for the exponent of the power law, n, from 2, which is quadratic, to 8. The running track profile geometry is evaluated based on the reduction of contact pressure and the equivalent stress. For the reference case of a quadratic profile, which corresponds to n equal to 2, we can obtain the Hertzian contact, that's the case of alpha equal to 0, for which the contact is only implemented in the center and is pointwise. And for the growing radius of the profile of the running track, we can obtain a more elongated contact spot. With a further increase of the radius, the contact may actually transform from the center to the edge of the running track. For higher power exponents n equal to 4 and n equal to 8, we will obtain either a pointwise contact in the center or the edge contact. The apparent optimum at alpha 0.5 and n equal to 2, which displays the lowest contact pressure and equivalent stress values, requires to cut the groove too deep. This will cause the interference between the rotor block and the inner wall of the stator. The feasible domain of the design parameters does not cover the entire parameter space, and hence the optimal design solution will be found somewhere on the boundary of the admissible parameter space. To conclude the talk, we can summarize that the developed models, methods, and analysis tools for contact interaction of contacting complex-shaped structural elements have demonstrated their utility and effectiveness. The parametric approach is based on the variable analysis of design solutions according to the strengths criterion. This makes it possible to validate progressive technical solutions of these structures. The developed analysis methodology can be applied to other machine components that transmit high loads through the contact interaction of complex-shaped working surfaces. And we would also love to acknowledge the financial support that was provided by a Eurozone grant and a National Research Foundation grant. Thank you for your attention.
Good afternoon. My name is Milica Tufekjic, and I came from the Academy of Professional Studies Šumadija from Serbia, and I want to present the paper Modeling Dynamic Response and Stability of the Combined Mechanical System with 2 degrees of freedom, written by me and my co-authors Sergej Kovalevski, Predrag Dašić, and Aleksandar Mišković. We all well know that mathematical models and transfer functions are used to describe the complex dynamic systems, their motions, and we can use some displacement, angular or translational, to describe dynamic behavior of combined mechanical system, including velocities and accelerations. But there is a lack of comprehensive analysis on the varying loading conditions when we talk about combined mechanical system, which has some rotational, disk Pauli component, and some translational, like masses, linear motion springs, and dampers. And there is no analysis in variation in design parameters, and also there is another gap that most of the papers only introduced translational or only pure rotational systems. We want to establish a system of differential equations, model and analyze dynamic behavior on combined system, and the focus is on establishing a system of differential equations based on Newton's law and dynamic equilibrium equations to describe translational and rotational movements. We have done this with MATLAB and Simulink and get some time domain solutions, and after that we have conducted some analysis in the complex domain and get some transfer functions. At the end, we visualize and compare results for comprehensive plots across different configurations of mechanical systems. For the purpose of this study, we have used some system presented here, disk pulley with the outer and inner pulley, massless rope which have spring of stiffness K1. We have 2 translational rigid bodies M3 and M4, their masses, and 2 additional springs with stiffness K1 and K3, and 2 dampers with its coefficients C1 and C2. Using the Newton's second law, we get these 3 equations, and where the second derivative of that represents the angular displacement, and the x3, second derivative of x3 and second derivative of x4 represent the acceleration of the bodies with masses m3 and m4. There is also some external force F acting on the body of mass m3. These equations are derived after decomposing such system on 3 elements: disk pulley, body of mass m3 and body of mass m4, and proper forces are presented here. Elastic forces that originated from the springs and damper forces that originated from the dampers. We can also calculate JC as the moment of inertia if we know masses of the pulleys and their R1 and R2. Using some expressions that between linear and angular displacement leads to the mathematical model presented with these 2 equations, and we can conclude that there are only 2 degrees of freedom due to the fact that only angular displacement and translational displacement completely described the dynamic behavior on the proposed system. For the simplicity, we introduced some coefficient A1 to A4 and B1 to B4, and some even more simplicity with the expression named with new variable named A. These are known parameters: masses, coefficient of stiffness, coefficients, damping coefficients, and some values for the inner and the outer pulley, represented with their radiuses, and we assumed that the force is constant and equal to 1 Newton all the time. After that, in order to analyze the influence of some element, we modified initial configuration and removed some elements like damper with damping coefficient C1, then removing the spring with the coefficient K2 and removing the spring with coefficient K3, and we have also derived mathematical models. First equation remains the same, and we used proper notations with indexes which indicated on the case theta 1, theta 2, and theta 3, and as well as translational displacements of the body of mass M4. And after that, we integrated all these equations in Simulink environment, making a model with zero initial conditions and with some blocks which are induced to connect MATLAB and Simulink with these Simulink blocks for each of the cases for theta and each of the cases for x. In order to get angular displacements in degrees, we have also induced this for gains. After that, we have converting the different equations from mathematical model into complex model in order to obtain the transfer function. We have used Laplace transformations to the left and right sides, and the transfer functions of the system are calculated, and after that some characteristic of these transfer functions are used, properties such as poles and zeros and gain factors determined in MATLAB. The dynamic of the system in terms of stability is also tested in MATLAB, and we have used Nyquist and Bode stability criteria. Running the MATLAB scripts as the result products some plots for all presented cases. This is Pulley rotations displacement. Here is presented the Pulley. Here are presented the Pulley's rotation displacement for each of the cases. As example, we have removed damper with damping coefficient C1 and get this brown curve, and after that removing the spring of stiffness K2, we get this green curve, and the stiffness at last, the spring of stiffness K3, we get this blue curve. Also, the initial case is also presented with the pink color. We have situation that this pulley is rotated clockwise and counterclockwise and have some amplitudes, the highest in the case of blue curve when the spring of stiffness K3 is removed from the mechanical system, but the decreases of these values are slowest during the observed period. On the contrary, the lowest amplitude values are for the initial system, represented by pink curve, and some similarities should be noticed between initial system and the system without the spring of stiffness K2 green curve. The period of oscillations are easy to determine from the plots, and it's near 0.5 seconds. The same thing is done with the translational displacement, also indicated on oscillatory motions of the body of the mass M4 for all cases, and the effect of removing damper with damping coefficient C1 is presented with the brown curve, the spring of stiffness K2 with green curve, and the spring of stiffness K4 with green curve, and we have seen some differences. This is especially the case when the spring of stiffness K4 doesn't exist, and oscillations, we can see at the blue curve, have complex nature and looks like undamping forced vibrations. On the other side, the initial system and the system without a damper show almost the similarities in the amplitude values and in the decrease rate. Some irregularities are presented at the initial period of oscillation in the case when spring of stiffness K2 is removed, and except, however, oscillations of the body are undamped. A period of oscillations has almost the same values as for the angular displacement, and is about 0.5 seconds. The transfer functions for all observed systems are also calculated, and we can see that the most complex expressions are for the initial and for the case free, and the denominators are polynomials of the fourth degree, and according to that both systems has 4 poles, and in the case 1 and 2 we have some simplicity and polynomial of the second order. We can see here initial system, 2 poles. Initial system in case 3 has 4 poles, and 2 with conjugate complex are conjugate complex, while the case 1 and case 2 are purely real. And finally, due to the fact that Nyquist curves do not include the critical points, we can conclude that all the systems will be stable after closing the feedback loops. One or the both margins, we can see here on the Nyquist diagram, gain and phase are infinite on each both diagram, which means that the system will always be stable no matter what is the gain increase. For the initial system, body phase plot crossover frequency is of 8.33, and for the case 3 it is 12.6 degrees. For the system in case 1, body magnitude plot displays 26.3 decibels for gain margin, with the gain crossover frequency equal to 0 radius per seconds. Finally, we have some conclusions. We have various configuration of the system investigated by deriving mathematical models for each case and simulating the pair time domain responses using MATLAB and Simulink. And we have explored the impact of removing elements such as springs and dampers on system dynamics. We have also conducted some analysis in the complex domain, and all the systems remain stable even under conditions of increased gain, and all the feedback loops were closed. We want to highlight the importance in component selection and configuration in achieving desired performance outcomes. At the end, thank you for your attention.
Hello everyone, this is a work by Letra, Olha Trofimenko, Vera Trofimenko, and Volodymyr Shevchenko. We would like to talk about the fundamental solution of the dynamics of thin isotropic plates lying on an elastic base. So, thin-walled structural elements in the form of plates are widely used in the modern mechanical engineering, construction, shipbuilding, aviation, and the requirements for the properties of such structures are constantly becoming more complex. Structural elements can be made from modern anisotropic materials with these special mechanical properties. The practical side of the use of thin-walled structures is that the use of plates and shells is the rational design solution because of their relatively low mass, cost-effective manufacturing, and at the same time their high load-bearing capacity and other useful technological characteristics. A plate is a solid body that has the shape of straight prism or a straight cylinder. You can see the example at the left side on this slide. And we have the h, the thickness of the plate, and it's a small compared to the dimensions of the base. We assume that this thickness of the plate is a constant. According to the specified criterion, the plates can be conditionally divided into the following groups. We can say it membranes, stiff plates, moderately thick plates, or thick plates. Experimental studies have shown that Winkler model is acceptably correct in cases of peat and silty soils, as well as for fine-grained water-saturated sands. And we can see like small example of Winkler elastic base on the right side of this slide. In the hands of soils, the use of Winkler model becomes incorrect and distorts the actual operation of a plate structure on an elastic foundation. Historically, the first model is based on the so-called Winkler hypothesis, which assumes a directly proportional relationship between the pressure on the thick ground and the pine settlement caused by it. Despite the fact that Winkler model was proposed more than 150 years ago, it still remains one of the most common elastic foundation models used in mechanics. We'll consider one of the possible improved mechanical models of a soil foundation, namely the Pasternak model of an elastic foundation with the two coefficients C sub 1 and C sub 2. And you can see the corresponding equation here on this slide. Basically, we have equation 1. So the coefficient of the elastic base C sub 1 characterizes the comprehensive stiffness of the base, and the coefficient C sub 2 characterizes the shear rigidity. And also, of course, if we will have case when C sub 2 is 0, basically we will have the Winkler model in this case. We consider the material from which the plate is made to be homogeneous, is an isotropic, and mechanical properties of the medium are the same at all its points, and at any point of the medium, its properties are the same in all directions. So in case of a static normal load coordinates x and y, we write the main equation for weak bending of a thin plate, and you can see this equation where q of xy is a transverse static load on the plate. In structural mechanical problems, as a rule, plates are not considered by themselves, but in some interaction with other structural elements or with some environment. So elastic foundation, and you can see like a small representation at the right side here, is one of the basic model concepts of the theory of structures. Let's demonstrate an algorithm for constructing a fundamental solution to equation of Pasternak model. So the algorithm proposed in the work for constructing fundamental solution of a plate dynamics is based on the joint use of the Fourier and Laplace integral transforms and the theory of special hypergeometric functions. So first of all, initial equation from previous slide, we'll have some special substitutions for this equation, and because we need to get the Pasternak model. So you can see the special substitutions at this case for the q of xy, for xyw. And of course, we have the substitutions for C sub 1 and C sub 2 coefficients. So we'll model the concentrated dynamic force section of an infinite force using the generalized Dirac delta function, and we can describe the next E of x, y, t. E will be called the fundamental solution to equation 1. We remember that equation 1 is basically Pasternak equation. If this W, basically E, will satisfy equation 1 at the load value Q, which is a delta function. So an effective method for constructing a fundamental solution to a partial differential equation is a method of integral transformation, of course. So science equation one depends on 3 coordinates in accordance with the methodology to solve. We will use the formula for the direct Fourier transform and also for the direct Laplace transform, as you can see on this slide, for F and L. And the use of integral transformations allows do not overcomplicate the mathematical specifics of the delta function. Why? Because we have this perfect result. In this case, for Fourier transform, in case of delta function, we have just 1 over 2 pi. And for Laplace, we have just 1. So if you have this result, if you have this result, in relation to equation 1, Pasternak model, basically, as I said before, the transformant of the dynamic deflection function of a thin plate will have the form like the first formula on this slide. But basically, we will move to the next formula at the center of the slide for WRT. And we can see this representation using the inverse Laplace formula. And also we have the improper integral as well as the G Bessel function of order alpha. And here also interesting is R's are polar coordinates in this case. So if you will use for the Bessel function the power series and also the Effort's theorem, we will have the next representation for WRT. Again, we have the inverse Laplace transform, but it seems like more complicated structure in this case. So we'll use the Effort's and Danilevsky formula, famous formula. Why? Because we have the same structure in our formula and at the left side for Effort's Danilevsky. And basically we will have the gamma and the R, and we will have the Bessel function again at the right side. So also, it's interesting that we can use technique for calculating improper integrals, and we are interested in special expression like at the left side here. So for this expression, we would like to use the improper integrals specifics, and we will have at the right side the most interesting part here. Basically, it's Maillard G function now. So the fundamental solution of the dynamics of a thin plate line on an elastic Pasternak base is represented on this slide. So WRT, and you can see the this expression. So we have this series. We have, of course, the coefficients C sub 1, C sub 2, and of course, as a result, I remember from previous slide, the Maillard G function. So basically, we have the answer. And also, it's interesting that in some case, when we have C sub 1 is 0, it means the lack of elastic base, we will get this solution. Like we can see, it seems more simple solution for R, for WRT, but it's only for the C sub 1 is 0, and it's a famous result for Zhigalko and Sadikov. So in some in more simple case, our formula works. As a conclusion, the fundamental solutions to the equations of dynamic deflection, thin isotropic plates that lie on an elastic base were obtained, the solution at this case, and we used the method of integral transformations of Fourier and Laplace. And we used the theory of special functions, and we used the method of analytical calculation of improper integrals by marriage. Also, at the end of our presentation, we would like to say that the presented work is a development of the methodology of academician Volodymyr Pavlovich Shevchenko, and this paper is one of his latest studies, and Volodymyr Pavlovich passed away this April, and we would like to dedicate this presentation to him. Thank you very much for your attention.
afternoon, dear head and participants of International Scientific Conference. Let me draw your attention to a scientific article on the topic Superconductivity of Friction Pair of Brake Devices, written by co-authors Dmytro Volchenko, Dmytro Zhuravlev, and Irina Bekish, Ivano-Frankivsk National Technical University of Oil and Gas, Vasil Skribnik, Nadvirna Vocational College of National Transport University, and Sergei Nikipchuk, Lviv Polytechnic National University. As we know, the entire body of the metal friction element and the surface layer of the polymer lighting of the friction pairs of brake devices have superconductivity. A special role is played by the so-called thread-like structures in the nodes of the crystal lattices of the materials of the friction pairs, which have a sufficiently high conductivity due to their low electrical resistance. The use of one-dimensional, two-dimensional, and three-dimensional conducting polymers with different superconductivity efficiently installed in polymer lighting from its descending surface to the advancing one will allow equalizing the surface energy load of the earth of the lining grip during electrothermomechanical friction. The external discreteness of the contacts of the microprotrusions of the brake friction pairs is characterized by internal discrete energy levels, which have an important feature. They are divided into groups representing zones of different widths with unequal electron mobility in them. Theoretical and experimental studies have established that when microprotrusions of friction pair vibrate, a Cooper pair of electrons is broken with the absorption of a quantum of the electromagnetic field photon and a quantum of sound phonon. The main task of this article is the use of one-dimensional and multidimensional conduction superconductors in the surface layer of the polymer pad, and the body of the metal friction element is possible due to the thread-like structures in the crystal lattice, which have a sufficiently high conductivity due to low electrical resistance and a decreasing jump in heat capacity. It also shows the main issues of the article in the purpose of the work itself. Let us consider the research work. Direct measurements of the head capacity of superconductors show that when the temperature decreases, the head capacity at the transition point from 200 to 400 Kelvin experiences a jump to a value that is approximately 2.5 times lower than its value in the normal state. In this case, the head of transition is zero. Thus, the transition of the superconducting state in the absence of a magnetic field is a phase transition of the second kind. From Formula 1 given in the article, one can obtain the values of head capacity in the superconducting and normal states. This relationship is confirmed by experiment. The thermal diffusivity was determined by dependence 2. With a jump in heat capacity in the superconduction, the thermal diffusivity will increase by 2.5 times. The expulsion of the magnetic field of the superconducting metal friction element of the break in the time intervals between breaking. Meissner effect occurs in the presence of an external magnetic field. The Meissner effect is associated with the fact that a circular undamped current appears in the surface layer of a superconducting cylinder, the strength of which is such that the magnetic field of this current compensates for the external field in the thickness of the superconductor. For the temperature at which conventional superconductors transition to the normal state, the formula 3 is obtained. From this relation, it is evident that the values of the superconductor temperature cannot exceed the Debye temperature. The exponential factor leads to a decrease in the superconductor temperature by approximately an order of magnitude, which corresponds to the observed low values of temperatures at which the effect of superconductivity is observed. The usual mechanism of superconductivity is associated with the deformation and polarization of the crystal lattice of the electron system of the metal. In 1964, a new mechanism of superconductivity was proposed. He considered a one-dimensional conduction polymer, the scheme of which is shown in Figure 1a. In addition to the main axis along which conduction electrons move, there are side branches, and the electrons related to them perform oscillatory motion. The presence of two groups of electrons is essential in this model. The numerical calculation performed in its work is very approximate, but the mechanism of superconductivity itself is undoubtedly very interesting. Its implementation, however, encounters fundamental difficulties. They consist not only in the need to create a very extended one-dimensional organic structure, the scheme of which is shown in Figure 1b. An example of an extended molecule is deoxyribonucleic acid, which plays an important role in the life of an organism. However, deoxyribonucleic acid has a helical structure. According to the band theory of solids, the state of an electron is characterized not by any, but by quite specific discrete energy levels, similar to the electron levels of an isolated atom. These discrete levels have an important feature. They fall into groups called zones. Figure 2 shows overlapping energy zones. Electrons belonging to a narrower zone are less mobile and are characterized, as they say, by a greater effective mass. Electrons belonging to zones A and B differ both in their effective masses and in the wave functions describing the quantum mechanical state. In both zones, there are unfilled energy levels due to which electron transition occur. Based on the results of theoretical and experimental studies of the state of superconductivity in friction pair of braking devices, it was established. The entire body of the metal friction element and the surface layer of the polymer lining have superconductivity. A special role is given to the so-called thread-like structures, which have a high thermal conductivity coefficient of 3-5 times due to low electrical resistance. The external discreteness of the contacts of the microprotrusions of the brake friction pairs is characterized by internal discrete energy levels, which have an important feature. They break up into groups that make up zones of different weights with unequal mobility of electrons in them. When a Cooper pair of electrons breaks, a quantum of the electromagnetic field photon and a quantum of sound phonon are absorbed when microprotrusions oscillate with a wavelength of 4-8 nanometers of the friction pairs. Thus, and it is shown by the studies presented in this paper, the superconductivity of a metal element is affected by the deformational and polarization of the crystal lattice of the electron system of the metal, which lead to interelectronic attraction and, as a result, contribute to the establishment of a superconducting state. The study of superconductivity in friction pairs in braking devices will subsequently lead to the fact that a recommendation will be given to reduce and wear of friction materials of friction pairs by 20%, which will lead to their more efficient operation. The results of theoretical and experimental studies can be used in decision office and factories as well as in further developments of friction pairs of brake friction units. The authors thank the Department of Technical Mechanics, Engineering and Computer Graphics of the Ivano-Frankivsk National Technical University of Oil and Gas, as well as the Department of Construction and Road Machines of the Kharkiv National Automobile and Highway University, and personally Prof. Volchenko Alexander for assistance in preparing the manuscript. Thank you for your attention.
Good afternoon, dear conference participants. Your attention is presented on the topic superconductivity of metal friction elements of brakes. And let's start with the first slide. So, in the solid-state theory, with a metallic friction element in the form of the cylindrical ring, the elastic oscillations on the crystalline lattice are described as the movement of phonon sound waves. Electron pairing occurs through the exchange of phonon or electron-phonon interactions. So what the aim and research tasks? Superconductivity in friction pairs is local. In this context, superconductivity assessments not only provide an opportunity to conduct new studies in braking devices, but also to improve their efficiency. The article touches upon such issues as general principles of superconductivity condition in braking pairs, Schrödinger equation, and the Bloch law. The objective of the work is to investigate superconductivity of the first and second kinds of metal friction elements of brakes. And we come to the research methodology. In the case of electrothermomechanical friction of friction pairs or brakes, an electric current is generated on their couplings, which facilitates the emergence of magnetic annual lines around the cylindrical metal ring, which you can see in the figure 1. Large currents will contribute to the emergence of the local superconducting state of the metal friction element. On the inner surface of the ring, magnetic lines will also appear. So, what's the general principles? Superconducting substances are prone to heat transfer processes and are capable, for example, of strong cooling with a relatively small heat losses. When the temperature of the superconductor becomes equal to the critical temperature, the transition to the normal state takes place and the thermal capacity begins to change according to the linear law. However, this transition is not continuous. In the figure 2, we can observe the heat capacities jump. Individual superconductors differ from one another by the magnitude of the jump, but the very fact of its existence is their universal property. In this slide, we can see two Schrödinger equations. The first one is for a particle I with a mass m moving under the influence of a force generated by a potential V. And the second one is for V if it doesn't depend on time. Here are some conclusions. Therefore, the electrothermomechanical friction interaction in the braking pass is considered in which an electric current is generated, which contributes to the formation of the magnetic annual lines around the cylindrical metal ring presented as drum and pulley rings. Theoretical studies of the superconductivity of metallic friction brake elements have allowed us to identify two groups of superconductors and to describe different interactions within the working surface. The state of superconductivity of first and second kind of metal friction elements of braking devices is estimated. The obtained results can be applied in the development and optimization of friction system, in particular in the study of shoe brakes of disc tube type of drilling winches. Here you can see Bloch law, dependence of spontaneous magnetization ferromagnets on temperature. The role of ferromagnets in brake friction pairs is performed by wear products between the microprojections thereof. So let's discuss more detailed about superconductivity of the first and the second kind in braking pairs. The superconducting state in the macroscopic quantum state of a metal. Based on their behavior in the sufficiently strong fields, superconductors are categorized into two major groups, those of the first kind and those of the second kind, which you can see in the picture 3. In the long-term braking mode of the drum brake, superconductors of the first kind lose superconductivity in the field. When the field jumps into the body of the drum frame and the last in all volume goes to the normal condition. At the same time, the specific magnetic moment also decreases by a jump. And the results. For space-limited systems, the solutions exist only for discrete energy values. These values are numbered as integral quantum numbers, and each of them corresponds to wave functions. The Bloch law allows the dependence of spontaneous magnetization of ferromagnets on the temperature and is well respected at temperatures well below in the Curie point. The decrease in magnetization with the increase in temperatures is explained by the disorder of the order orientation magnet moments of matter under the influence of thermal motion of particles. The role of ferromagnets in friction pairs of brakes is performed by wear products between microprojections. The results of theoretical studies of the state of superconductivity of first and second kind at low and high temperatures of metal friction elements of brakes have revealed the following. The first group includes so-called superconductors of first kind cooling with surface positive energy. The negative side of surface energy characterizes the superconductors of the second group. Next, the top layers of the working surface actuated by the action of friction forces and pulls normal forces between which the equation, which you can see in the screen, is correct. In this case, they interact with the crystal lattice. Third one. The lower layers located on the non-walking side of the surface experience the internal interaction between the paired Cooper electrons and the crystal lattice. Next, electric, magnetic, and thermal gradients decrease in the size from external to internal effects. And the last one, the presence of different types of contacts and their transformation connected with the electrical resistance promoted superconductivity of the local character of the first kind. Thank you for your attention.
Greeting, dear colleagues, on the platform of such an influential conference. My name is Maxim Stoda. I am an associated professor at the Technical University Metinvest Polytechnic. For your attention, I would like to present a paper on stress and strain state of bar in the space between the stands of a continuous shape rolling mill. The continuous rolling method is currently the most common in producing long products. It is known that the distribution feature of continuous rolling is the similarity of deformation in several successive stands of the mills. It is important to note that in many areas of rolling production, these features play a positive role. At the same time, in section rolling, on the contrary, the presence of roll tension between stand or groups of stand leads to noticeable decrease in the accuracy of rolled products. Therefore, they try to roll the section profiles in a mode in which the strip tension between the stands is minimized. For several reasons, such adjustment of equipment is extremely difficult in practice, which is most true for high-speed wire block. Here the main question arises in the practice of section rolling. How exactly does the setting of the mill finished block affect the mode of rolling speed and the mode of tension bar? There is still no reliable information about the relationship between the magnitude of mismatch between the speed regime of adjacent stand and the magnitude of the tension in the strip between the stands in technical literature. This makes it impossible to calculate both the value of the deformation of the metal during rolling with tension and backwater and the rolling speed regime. The influence mechanism of the rolling force on the strip's shape is still currently unclear. Difficulties in calculating the modes of continuous rolling also arise in connection with the state of the modern theory of rolling, which states that in many cases the effect of frontal tension can be neglected. The theoretical part of the work was carried out in the software package for modeling and optimizing metal forming process reform. Before proceeding to a theoretical study of the process of continuous section rolling, the influence of software setting in the simulation of free rolling in Q-form on the accuracy of the calculation results was analyzed. The purpose of this part of the work is to determine and adequate law of friction that describes the contact conditions in the deformation zone when modeling the rolling process in the calibers of simple shape in the Q-form so far products when setting task to obtain practical data which will be the basis for determining adequate contact conditions in the simulation. Lead sample of circular cross-section were rolled in the laboratory with the dimensions indicated in the drawing in this figure. The experimental part of the work was carried out on the mill 220 with the speed roll 100 rpm. To obtain different values of the friction coefficient at the contact of the billet with the rolls, the samples were either decreased or covered with soap or chalk before rolling. The results of measurement of samples before and after rolling on laboratory mill are given in this table. This figure shows that the results of calculation according to the Coulomb law of friction are closest to the experimental data. The laws of friction and Sibyl and Levanov cannot be used to model the process of rolling in calibers. It is recommended to use the Coulomb friction law with the friction coefficient doubled compared to its real value. To test the adequacy of the finite element model of section rolling with front tension on laboratory mill, a practical part of the experimental was carried out. Round workpieces from lead were the nominal diameter of the cross section of 5.06 to 7.71 millimeter. The front tension was created using a block load mechanism showed in this figure. The results of laboratory studies are presented in this table. Further, the conditions of laboratory studies were reproduced in the simulation in Q-form. The results of calculating the broadening coefficient in Q-form are presented in this table. As you can see, the error does not exceed the engineering error. To check the performance of the Q-form model of section rolling with front tension, the simulation results were also compared with the results of calculations using the experimental formula. This figure shows that the nature of the change in the broadening coefficient depending on the parameters of the rolling processes corresponds to practice, that is the process of rolling round bars in oval calibers with front tension is adequately described by the simulation result in Q-form. The results of calculations of the broadening coefficient according to formula for cases implemented in the laboratory are graphically presented in this figure. The results of mathematical modeling of the process of continuous section rolling show that there is a close relationship between the value of the kinematic stretching, the dimensions of the wire rod, and the value of the longitudinal stresses in the rolled metal between the pre-finishing and finishing stance. So, with an increase in the kinematic stretching, the width of the wire rod decreases and the longitudinal stress tension increases. In all the studies cases, the dimensions of the wire rod do not meet the requirements of the standard, either in terms of ovality or width accuracy. To obtain a wire rod of the required accuracy, it is necessary to adjust the reduction mode. It is important to know that changing the gaps in the wire rod block not only changes the size of the metal, but also changes the force interaction between the stance and the strip. This interaction is typically not considered in existing engineering calculation methods. At the same time, the proposed mathematical model of continuous section rolling, which was implemented in Q-form, automatically considers the force influences from all rolls of the system on the deformed metal. The subsequent study of the effect of changing the setting of the prefinishing and finishing stance on the wire rod showed the high efficiency of this method. If round profile with a diameter of 6.9 millimeters is used as a roll for an oval caliber, and at the same time the gap in the finishing pass is reduced by 0.1 millimeters and the gap is increased by 0.4 millimeters in the pre-finishing pass, then the dimensions of the wire rod will change to 5.4 millimeters. A further increase in the gap in the pre-finishing oval by 0.4 millimeters make it possible to obtain a wire rod with the tolerance range 5.4 in the hot state or 5.36 millimeters in the cold state. This is ultimately by changing the setting of the last tenths of the block obtained high quality wire rod with a minus tolerance on the diameter. Analysis of the calculation results shows that a change in the gap between the rolls of the last two stands of wire block can lead to appearance of strip of longitudinal stressing or compressive stress in the metal between the stands. Thus, the results of theoretical studies showed that a change in the size of the gaps of the rolls significantly affect not only the dimensions of the profile after rolling, but also the stress state of the rolled metal in the space between the stands. The use of the results of work in automated systems of wire rolling mills make it possible to develop innovative resource-saving technologies to produce wire rods on existing equipment with a reduced consumption coefficient compared to existing ones. The author of the article expressed his gratitude to all the employees of Mika Simulations and personally to Nikolai Biba for the ability to run simulation in Q4. Thank you for your attention.
You can start.
So, dear participants, we return to our question room. It was a very interesting section, and I hope that all of you has the same opinion. And now we are starting with question. And the first report which we have listened, it was design of a helical shredding dream blade and determination of its unfolding. And maybe someone have a question. Okay, we have not speakers in the room, and we will send them question in the mail. The next slide, the next presentation was contact interaction of a bell with a toroidal running track with a closely shaped power law profile. And do we have the speakers in the room? Okay, and maybe someone have a question to the speakers?
Static contact. So we neglect dynamic forces.
Yeah. No, really,
I mean,
really,
your equipment work only in dynamics variant. Yeah.
Yes, it's true, but it can be considered as quasi-static. So when we compute the forces that's acting on the ball pistons, we account for the ball inertia and so on. But truly speaking, those forces do not affect that much the stress state of ball bearings. So, not ball bearings, but of ball pistons.
And how your opinion? What is optimal radius ball and radius подшипник, как его?
Curvature.
Да. What is optimal?
So actually, the optimal would be the radius of the running track, because we have a running track, which is like very, very close to the radius of the ball. But it cannot be implemented into the design, because there will be just interference of parts. So we can do this groove on the stator ring. So that's the internal surface of the stator. Only actually, I think up to 3 millimeters deep, and that depends a lot on the design. So because otherwise, so on the maximal eccentricity of the hydraulic motor or hydraulic pump, so there will be just the rotor itself will then be sort of shaving into the stator otherwise. So an exact optimum, so that depends a lot on the design of the entire machine. But what we do, we just provide the relation and of maximal pressures and contact pressures, and it's the designer who has to decide how deep of a groove he can afford in these designs so he can fit. So that question needs to be answered by the designers of the machine.
Okay, thank you very much.
Thank you for the question.
Maybe someone more have a questions? If no, I have my question.
We can continue now.
So very good, and we continue with next presentation. It was presentation number 4, and this presentation was titled "A Fundamental Solution of the Dynamic of Thin Isotropic Plates Laying on an Elastic Base." And maybe someone have a question to the speakers.
I have a small question.
Do we have a speakers?
Possible.
Yeah.
In Pasternak law, we have parameter time. Really, I don't understand. You study your process with time or not?
Do you mean if it depends on the time?
Да. That depends on the time.
Not really, not depends on the time. About the coefficients, what you said, there are two main coefficients, and it's not about the time too. So.
Your task is only no, without time. Static time. Static without time. Okay.
Yes.
Understand. Thank you very much.
Thank you.
So, and little question from me. Also, I want to current task, your result could be most applicable.
From my point of view, I'm more like a mathematician. I was interested in theoretical part and that formulas. My colleagues there are more in mechanics, but what we know, what we discussed, kind of for what we can try, it's an isotropic case, for example, and also it's can be interesting in the BEM boundary element method to this to use this result, these solutions.
Thank you very much. And we have one more question from the Professor Mykola Tkachuk. Please ask your question.
Interesting. So again, Winkler Foundation is an interesting topic. My question is, so with regard to the plates, how does the addition of Winkler Foundation affect the dispersion of your elastic waves in thin plates?
Do you mean the additional effect of?
So yeah, so we have our plates. So and then you add additional foundation. So you have this elastic force coming from a local deflection, and so that changes the equation, but that also must change the propagation of waves, so how they disperse.
Yeah, so basically changing was realized by the substitutions, and there is a was slight disconnection between the first initial model, but not so effective, and Pasternak model. I didn't show the equation at the middle, but it's kind of the substitutions.
Okay, thank you.
Yeah.
Thank you very much. And
or it's tried the anisotropic case to continue the research of the Professor Shevchenko.
thank you very much. And also we have a question from Professor Vitaly Ivanov.
Are you currently in the United States?
Yeah.
But it is late night now.
It's it's 4 a.m. in
Thank you very much. Our appreciation
For joining us. Thank you very much.
Thank you.
Thank you and good luck.
Thanks.
So, and I propose continue, and do we have a
small question? I don't know. You use a term kinematic stretching. Kinematic stretch. What is kinematic stretch?
I'm very sorry, but also the speakers don't join to us, and I have also the question to the speakers. And this question we also will send to the speakers by the mail.
I understand. On next conference.
I think that our question finished, and now I want to thank the participants.
No. We have one more presentation presented by Professor Maxim Stoda.
Yes, and
Это что да?
I'm sorry. And this presentation about stress and strain state of a bar in the space between the standard of a continuous shape rolling mill. And do we have the Professor Maxim on the room?
He was here.
So it means that finish. We are finished. Yes. I thank the participant for their interesting presentation. My special thanks go to each participant in today's discussions. I hope that this event will provide stimulus and inspiration for new research and new achievement, maybe new contacts. I wish everyone kindness, peace, and inspiration. It was a pleasure to be with you today. And thank you very much for all. And be safe.
Thank you very much to Dr. Evgenia Basova for this 2 hours chairwoman person. Thank you very much for your dedications, for your time, expertise, and thank you very much to all participants for your contribution, participation, and answering the questions. Good luck in your future research, and see you in 20 minutes within the next session. Session number 10, Quality Assurance. I invite you to join us. Thank you. See you. Please start, Slomir.
Okay. Hello, everybody. Welcome to the session number 10, Quality Assurance. The last session, as far as I can recognize, the conference InterPartner 2024. My name is Sławomir Luściński from Kielce University of Technology. I am related to this conference from the very beginning, including twice presence personally at Odessa. I hope next time we'll meet again with our colleagues from Ukraine and other countries. So the agenda of our session is as follows. The first paper will be presented by the Konstantin Diadura, Igor Prokopovich, Vital Kamitov, Tetiana Sikacz, Aleksandr Vershkov. That's the paper which is titled Application of the Dynamic Programming Method in Process Measurement Problems when Assessing Interoperability. The team is from Odessa Polytechnic National University, and Dmitro is from Tavria State Agri Technological University. The second presentation is from our colleagues from Tavria State Agro-Technical University and Institute of Pedagogy of National Academy of Educational Sciences of Ukraine and Technical University Kharkiv Polytechnic Institute. It will be titled Monitoring the Accuracy of Manufacturing Elements of the End Distribution System of Hydraulic Motor Planetary Type. The third one is from our colleague of Odessa Polytechnic National University, also from Academy of Professional Studies, Sundia, and State University of Intelligent Technologies and Telecommunications. And it's titled Improvement of the Technology of Production of Packaged Mineral Sodium Chloride Water using the Principles of Risk Management. The fourth presentation is titled Improving the Quality of Emulsions, Dispersion Impulsation Homogenizer using Computer Simulation. It comes from our colleagues from still once again Motorny Tavria State Agro-Technical University and Dnipro State Agrarian and Economic University. And the last presentation is this session as the simulation of the process in composite materials under thermometrical control, taking into account their heterogeneity. And it comes from the team of the chair of our conference, Professor Vladimir Konogi, and her colleagues from Odessa Polytechnic National University of Ukraine, Academy of Science and Arts, Bosnia and Herzegovina. So, accordingly to the agenda, let's start with the presentation. The presentations, as you already know, will be presented once by other without breaks, and after broadcasting all of this presentation, we'll switch to the interactive part of the session. So, okay, the internet is now for the presentations.
Dear colleagues, good morning, afternoon, ladies and gentlemen. Let me introduce myself. My name is Konstantin Diadura. I am from Ukraine, Odessa city. I am a researcher and teacher of Odessa Polytechnic National University. The topic of my presentation is application of the dynamic programming method in process measurement problems when assessing interoperability. Introduction and major challenge. The development of various technology and software forms and methods of storing, processing, and distributing information has determined the wide implementation of multiple information and technical systems. Complex systems have a multitude of different characteristics. Decisions are made taking into account the results of the assessment. The research in the work is aimed at obtaining and using new knowledge regarding the prospective assessment of the life cycle processes of complex technical systems, taking into account the potential opportunities and types of activities of machine building enterprise, the type of products there are manufacturing, the requirements of technical regulations, conformity assessment procedure, as well as an energy efficiency assessment criteria and impact of the environment. Aim and research tasks. The purpose of the work is to create scientifically based approaches to the assessment of indicators of complex organizations and technical systems and process based of simulation and statistical modeling. New knowledge will be gained regarding the prospective assessment of processes that accompany the design, creation, and operation of complex organization and technical systems. Research methodology. Complex technical systems were studied as complex non-linear systems, the state result of processes, relationships between them that can change qualitatively and quantitatively when the external environment changes. To describe them, it is proposed to use non-linear mathematical equations. The main idea of the research is to create new methods and improve existing approaches to decision making at the stage of the life cycle when using system-wide evolutionary transdisciplinary models that take into account the cross-industry interactions of complex organization and technical systems during design, manufacturing, and operation, depending on the dynamic change of internal and external environment. Formative and informative measurements of process capabilities. The work develops methods for assessing the capabilities of interoperability of process of complex organizational and technical systems following the requirements of the ISO standard. A process is defined as a sequence of interoperability procedures, operations, or the steps that consumes resource and transform inputs into outputs. The relationships between the structure and the measurements. The goal of an informative measurement model is to measure its single properties by taking multiple measurements, while formative models attempts to summarize multiple properties into a single composite value. The relationship between a construct and its dimensions. The measurement system can be structured into a set of levels, the achievement of which is expected to be achieved by process control. We will assume that process control is described by a linear differential equations, where x is a vector of output coordinates of n dimensions, u is the control vector of y measurements, excellent is vector of distribution influence of m dimensions with statistical characteristics described by formula. A, T, B, T, GT functional is matrix of variable coefficients of corresponding dimensions. The results. A process capability level is characterized by one or more properties that represent the formative dimensions of the process capability. Process properties are necessary to construct process capabilities. Process properties are demonstrated by corresponding process property result that represent informative measurements. The properties of the process will be described by a system of different equations. The simulation, you can see this slide, simulation result of KIGT at different values of 4, lambda 11, lambda 12, lambda 21, lambda 22, 0. A grabs K11, B grabs K12, C grabs K22. This slide you can see the functional of simulation results of KIG values T at different values of 4, lambda 11, lambda 12, lambda 21, lambda 22. And then you can see a picture A grabs K11, B grabs 12, C grabs K22. The robustness of the composite value is assessed by uncertainty analysis of sensitivity analysis. Uncertainty analysis examines the degree of uncertainty in the input factors such as the distribution of values across the structure of composite dimensions and the impact of the composite value. Sensitive analysis tests the extent to which each individual source of uncertainty contributes to the final variance. Sensitive analysis can be performed based of process properties, incorporating weights into a composite measurement such as most compensation models requires a sensitive analysis for the weights where the weight ranking method must be specific. Proposed criteria for evaluation, the efficiency of the applications of conceptual schemes of the system of standard at enterprise depending on the possibility and directions of activity. The obtained results, the theoretical and practical informational materials, new knowledge that contributes to the development of the theory of decision making and the theory of the optimal management of the life cycle process of complex technical systems depending on the capabilities and directions of activities on enterprise, the types of products, the requirements of technical regulations, conformity assessment procedures, as well as criteria for assessing energy efficiency and impact of the based on the result of the context analysis, we identified the following four challenges: comparability, scaling, issue data availability, and uncertainty. However, we have included the scaling issue in the date call because scaling is required to generate inventory date for scaled product system. Thank you for attention.
Dear colleagues, your attention is presented with a report on the topic, monitoring the accuracy of manufacturing elements of the end distribution system of a planetary hydraulic motor. 1. Introduction and major challenges. Currently, the mechanical engineering industry has accumulated quite a lot of experience in the production of gear and axial piston positive displacement hydraulic machines, as well as elements of their distribution systems. This experience cannot be fully used in the production of planetary, orbital, hydraulic machines due to their specific design features, particularly the distribution system. The end distribution system is designed to ensure the functioning of a hydraulic motor planetary type by creating a rotating hydraulic field of the working fluid. The uniformity of the supply of working fluid into the working chambers of the hydraulic motor planetary type depends on the accuracy of manufacturing of the elements of the end distribution system. 4. Monitoring the accuracy of manufacturing elements of the end distribution system of a hydraulic motor planetary type for the purpose of stable operation of planetary hydraulic machines is an urgent problem. 2. Aim and research tasks. To improve the stable operation of planetary hydraulic machines, by ensuring control of the accuracy of manufacturing elements of the end distribution system of a hydraulic motor planetary type, it is necessary to solve the following problems. Justify the controlled parameters of the elements of the contact surfaces of the movable and fixed distributors. Develop a scheme for determining the flow area for high and low pressure zones of the distribution system of a hydraulic motor planetary type. Determine the influence of the manufacturing accuracy, location, of the holes of the movable distributor on the pulsation of the working fluid in the distribution system, which determines the stability of the functioning of the hydraulic motor planetary type. Justify the tolerances for the angular arrangement of the working holes of the distributor during their manufacture. 3. Research methodology. The end liquid system distribution of a hydraulic motor planetary type is represented by movable and fixed distributors. On the contact surface 1 of the movable distributor, there are working openings 2 necessary for the supply, discharge, of working fluid to the working chambers, as well as discharge openings 3, used as working ones. To balancing the forces arising between the distributors during operation of the distribution system, there are relief holes for on the contact surface 1. The operation of the end liquid system distribution is to form a rotating hydraulic field of the working fluid supplied, discharge, to the working chambers. A rotating hydraulic field is formed by sequentially combining working holes 2 of the movable distributor, with holes 6 and 7 of the fixed distributor, located on contact surfaces 1 and 5. When the movable distributor rotates, its working holes overlap with the distribution holes of the fixed distributor. The overlap area of all holes determines the total flow section area of the hydraulic motor and liquid system distributionis. In this case, deviations from the accuracy of the angular location of the working and distribution holes cause pulsation of the flow section, and therefore affect the stability of the hydraulic motor planetary type as a whole. Pulsations of the total flow section area cause pulsations of the working fluid pressure, in the end distribution system of the hydraulic motor planetary type. Elimination of pulsations of the total flow section area, working fluid pressure, is carried out both at the design stage, the manufacturing stage. At the design stage, this issue is resolved by using the unloading holes of the movable distributor as working holes with their subsequent rational displacement. At the manufacturing stage, the stability of the total flow section area is ensured by monitoring the accuracy of the angular location of the working and distribution holes of the distributor. The main angles for monitoring the manufacturing accuracy of the location of the distributor holes are the opening angle of the holes epsilon and the angles of location of the holes of the movable alpha and fixed beta distributors. Justified controlled parameters of the elements of the contact surfaces of the distributors made it possible to develop a design scheme for determining the flow area for the low pressure zones of the distribution system. 4. Results. Studies of changes in the flow section area depending on the accuracy of the location of the distributor holes during their manufacture were carried out using the example of the end distribution system of a serial hydraulic motor planetary type of the PRG-22 series. The end liquid system distributionist of this hydraulic motor has a 7/6 kinematic diagram, which means fixed distributor has 14 holes, 7 high pressure, and 7 drain, and the movable one has 12 holes, 6 working and 6 unloading. For a hydraulic motor of the PRG-22 series, the number of working chambers is equal to the number of teeth of its internal rotor 9. Therefore, the structurally fixed distributor has 3 additional working windows made on the basis of unloading. The research results show that when the tolerance for the location of the centers of the working holes changes from ±10 minutes to ±60 minutes, fluctuations in the flow section area of the end distribution system range from 20 mm² to 65 mm² in the range to 300 mm². It has been established that fluctuations in the flow section area, obtained with subject to location tolerance of ±10 minutes, are comparable to fluctuations in the flow section area with an ideal, without deviations, arrangement of the distributor holes, columns 4, 5. This range, 20 mm², of change, fluctuation, of the flow section area is the basis for justifying the tolerance ±10 minutes on the location of the holes. At the next stage of the research, changes, fluctuations, in the flow section area of the end distribution system depending on the angle of rotation of the movable distributor were established. The analysis established that after shifting the working holes according the amplitude of fluctuation of the flow section area decreased by 2.3 times, and the frequency increased by times. Curves 1, 2. Such changes indicate the stability of the flow of working fluid passing through the end distribution system of the hydraulic motor planetary type. Research shows that with a tolerance of ±10 minutes, the pulsation frequency of the flow section area remains unchanged, and the amplitude has increased by 1.3. Curves 2, 3, which is within acceptable limits. A further increase in the tolerance field by ±20 minutes, ±40 minutes, and ±60 minutes, respectively, shows that the pulsation frequency of the flow section area does not change with an increase in the numerical value of the tolerance field. Curves 4, 5, 6. It should be noted that the amplitude of fluctuations in the flow section area increases by 2, 3, and 4.3 times, respectively. Curves 4, 5, 6. Such fluctuations in the flow section area cause pulsations in the pressure of the working fluid. Negatively affects the operation of the hydraulic motor planetary type as a whole. The conducted studies made it possible to determine the influence of the manufacturing accuracy, location, of the holes of the movable distributor on the frequency and amplitude of pulsations of the working fluid in the distribution system, which determines the stability of the functioning of the hydraulic motor planetary type. Tolerances for the angular location of the centers of working holes in the manufacture of a movable distributor are justified. 5. Conclusions. As a result of studies, the controlled parameters of the elements of the contact surfaces of the distributors were substantiated, which made it possible to develop a calculation scheme for determining the flow area for the high and low pressure zones of the distribution system. The influence of the accuracy of the location of the holes of the movable distributor, established by research, allows to determine the amplitude and frequency of pulsation of the working fluid in the distribution system, which determines the stability of the functioning of the hydraulic motor planetary type even at the design stage. Thank you very much for your attention.
colleagues, packaged mineral waters is increasingly being used as drinking water. Groundwater, unlike surface water, is less contaminated. However, it is necessary to take into account the possibility of non-compliance risks due to the packaging process. The European consumer is protected by the introduction of food safety management systems. Today, Ukraine is introducing European requirements for mineral water. According to directive, the nitrite ion content in mineral water is much stricter, 0.1 mg per liter, compared to the national standard, 2 mg per liter. Problematic in terms of nitrite content are mineral waters containing ammonium ions, some of which can be oxidized to nitrite as a result of nitrification. More often these are sodium chloride mineral waters with mineralization 1 to 5 gram per liter. For the proper functioning of food safety management systems, all risk of obtaining non-compliant packaged mineral water is increasingly being used as drinking water. Groundwater, unlike products, must be taken into account. So the work aims is to improve the technology for the production of packaged mineral sodium chloride water through the implementation of the ISO 22000 standard on product safety management using the principles of risk management. The object of the study was a plant for the production of packaged highly carbonated sodium chloride mineral water, which is packaged using groundwater from 3 wells. The study consisted of 5 parts. The first stage is a selection of the object of research. The second, analysis of monitoring data of the main chemical composition. The third, study of packaged mineral water production technology. Development of proposals for its improvement. The fourth, formation of HASP team, identification of hazardous factors of production. The fifth stage, development of a system for monitoring mineral water safety indicators. Mineral water from wells have an increased ammonium content, some of which can be converted to nitrite ions during packaging. Therefore, the risk of exceeding of content of nitrite ions in the finished product were studied. The basic chemical composition of mineral waters, mineralization and macrocomposition is stable. However, in water wall number 20 and 21 recorded singles exceedance of the condition fluoride content. To predict trends in change in indicators, a linear approximation function for the following form was used. Based on the results of the calculation of the approximation function of mineral waters indicators, it's determined that the fluctuation in the next 20 years should be within the norms of the approved conditions. As part of the study, the results of low nitrification in the well number 1220 is an excess of ammonia due to the presence of ammonium mineral water packaging bacteria and the absence of nitrites. The HASP team identified the hazards of packaged mineral waters production. Then they conducted a risk assessment using the failure mode and effect analysis method. The probability and effect range from 1 to 4. The HASP team identified the following 3 critical control points: water intake from the source, saturation by carbon dioxide, and capping bottles. At the fifth stage, a scheme of technical, chemical, and sanitary microbiological monitoring of the packaged mineral waters production process was developed. Table 2. Table 2. Critical limits, monitoring procedures, and corrective action for each critical control point. The information from Table 2 was used to develop the operational programs and prerequisites and draw out the HASP plan. Monitoring of the safety and quality of packaged mineral waters can be effective only if there is an implemented food safety management systems. Using the principle of HACCP and accordance with ISO 22000 and risk management, an analysis of risk of hazardous production factors was carried out. The assessment was carried out. 3 critical control points of the technology were identified. Their critical limits, monitoring procedures, and corrective action were developed. The applied organization approach, the implementation of the effective food safety management system, prevents the risk of contamination of mineral water in the process of its production and ensures the safety and quality of finished products for consumption. Thank you for your attention.
Dear participants of the 6th Globchenko's International Conference on Advanced Manufacturing Process, InterPartner 2024, let me to present to your attention a report on the topic, Improving the Quality of Emulsions Dispersion in the Pulsation Homogenizer using Computer Simulation. The urgent task of mechanical engineering is to improve the efficiency of equipment for the preparation of finely dispersed emulsions, homogenization. This process and the corresponding equipment are widely used in agriculture, chemical, pharmaceutical, processing, and other industries. Modern homogenizers have 2 problems. Either extremely high energy consumption or low quality of homogenization. The problem of extremely high energy consumption for the dispersion process is most actually identified in the food and processing industries, especially in the dairy industry, where the process of milk homogenization is decisive in the technological line of milk processing and production of drinking, ultra-pasteurized, unpasteurized milk, fermented milk products, cheeses, and milk preserves. Therefore, establishing more energy-efficient methods of homogenization and appropriate equipment for obtaining finely dispersed emulsions is highly relevant. The research aim is to determine the main hydrodynamic parameters of the homogenization process in the pulsation homogenizer and to check the effectiveness of its operation in practice. Research tasks to conduct computer modeling of hydrodynamic processes in the pulsation homogenizer, to experimentally investigate the process of homogenization in such a device and establish the quality characteristics of the final result. The study of the effectiveness of the pulsation homogenizer had been conducted on the example of milk, but it can be used for any other finely dispersed emulsions. To study and calculate the speed of the flow on milk in the pulsation homogenizer, computer modeling was used with software for computer analysis of hydrodynamic process, NC's workbench, and ITC CFX model with allows efficient and reliable calculations of fluid and gas dynamics. Based on the previous studies and 3D model was designed working chamber of a pulsation homogenizer using the SolidWorks design automation system. This slide shows a working chamber model of a pulsation homogenizer in SolidWorks software, which consists of cylinder, rod, shock pistons, inlet pipe for raw milk, outlet for draining the finished product, and crank device. Subsequently, the model of the working chamber of the homogenizer was transferred to the CFX model, which is located in the ANSYS Workbench software. To obtain more accurate calculated values of gas and liquid dynamics, a new version of the ANSYS Mission Grid system was used. This slide shows the geometrical parameters of the pulsating homogenizer and the physical-chemical properties of the milk, which were entered as input data for the calculation in the ANSYS bench program. For the convenience of research, the calculation was carried out for two different zones. The zone of milk flow through the channels in the shock pistons, and the zone of emulsion flow in the opening between the working chamber and shock piston. An experimental sample of the pulsation homogenizer was developed at the Dmytro-Motorny State Agro-Technological University, which is shown on this slide. The device consists of a working chamber of the homogenizer with reciprocating shock elements, which are driven into oscillating motion by an impulsive drive through crank mechanisms with an amplitude regulator. The main striker piston is rigidly fixed to the rod, and the second shock piston is connected to the first piston by means of spring elements. Calculations of the unsteady flow of milk emulsion was carried out in the range of amplitude fluctuations 12 mm. This range was further divided into 6 parts. Approximation equations of the degree of homogenization is presented on this slide. The result of the computer modeling and calculations were 3D graphs of the speed and pressure values during homogenization when the flow of milk passes through the opening between the shock pistons and the working chamber of the device and through the channels in the shock pistons at different values of the pulsation amplitude is presented on this slide. Fig A shows the pressure value and Fig B the rate of milk flow through the channels in the shock piston and the opening between the shock pistons and the working chamber of the device. In addition, part of the milk flow will pass through the hole between the shock piston and the working chamber of the device. So, based on the data obtained during the ANSYS Workbench calculation, a corresponding dependence graph was constructed, which is presented on this slide. As can be seen from the graph, the milk flow speed when passing through the gap between the impact piston and the cylinder of the working chamber of the pulsation homogenizer increases with the increase in the oscillation amplitude, and therefore it can be assumed that the degree of homogenization will increase accordingly. However, the pressure that is formed during pulsation homogenization also increases in accordance with the increase in the amplitude of oscillation, and therefore the energy costs for the homogenization process increase. Therefore, in the future, we decided to accept the optimal data for carrying out calculations, namely the pulsation frequency 55 Hz and the pulsation amplitude of impact pistons 10 mm. The next stage of the research was to determine the milk flow speed at the exit from the holes of the first and second shock pistons.
From the graph obtained, it can be concluded that the highest value of the flow rate in the precession homogenizer is formed at the exit from the holes of the second impact piston, thus confirming the feasibility of installing an additional piston to improve the quality of the finished product. To verify the analytically obtained data, experimental studies of the precession homogenization process were carried out to determine the degree of dispersion of milk fat. The obtained data were compared with the data of homogenization in a Wolff homogenizer. The results show that the diameter of milk emulsion fat particles is smaller when using precession homogenization. That is, the quality of homogenization in the experimental homogenizer become higher by 90%. At the same time, the uniformity of the fractional composition after processing in the experimental homogenizer is no less than that of the reference Wolff homogenizer. Conclusions. Research of technological equipment for dispersing finely dispersed emulsions made it possible to identify a promising and effective type of homogenizer, the precession one with 2 pistons. Computer modeling of the precession homogenization process in ANSYS workbench indicates that the maximum speed value when the emulsion flow passes through the channels of the second impact piston will be 3.4 to 4.5 meters per second when passing through the hole between the shock pistons and the working chamber of the device, 3.2 to 3.8 meters per second, while the value of the precession amplitude is 10 to 12 millimeters, and the pressure generated in the middle of the homogenizer 1.44 to 1.49 megapascals. These parameters indicate the creation of hydrodynamic conditions sufficient to obtain a high degree of dispersion. The conducted experimental studies showed that, firstly, the diameter of fat particles of milk emulsion is 0.18 micrometers, and secondly, the uniformity of the fractional composition after processing in the experimental homogenizer is no less than that of the reference Wolff homogenizer. The conducted studies prove that the experimental precession homogenizer with 2 pistons is not inferior to the reference Wolff homogenizer in terms of homogenization quality. Thus, the experimental homogenizer is promising for replacing Wolff homogenizers and requires further in-depth research in order to determine energy consumption and introduce it into production. Thank you for your attention.
Dear colleagues, your attention is presented to the work called Simulation of Process in Composite Materials under Thermometrical Control, taking into account their heterogeneity. Nowadays, there are technical and economic prerequisites for the widespread using of non-metallic heterogeneous materials in the engineering industry. The multi-level nature of such materials provides ample opportunities for the synthesis of their physical and mechanical properties, which are manifested and accordingly can be evaluated through the interaction with other objects. At the same time, the main attention should be paid to the defects that occur during the production of products or as the result of their operation. The effectiveness of the using of heterogeneous materials and constructions from them requires the measurement of reliable values of the parameters of internal processes occurring in them at various stages of operations. In this work, consider the acoustic infrared thermometric method of defectoscopy of products made of non-metallic heterogeneous materials in which thermal energy is generated at defects in the structure under the influence of vibration, which is primarily due to the dissipation of vibration energy in the place with structural theaters. It is also possible to note the specific of using of a particle method of non-destructive testing, as well as the physical phenomenon manifested in non-metallic heterogeneous materials during the vibration effect on them, have not been fully studied for its particular application until now. The solution of such problems as the development of improvement of methods for measuring parameters of processes occurring in composite materials must be performed with knowledge of specific theories of mathematics, taking into account the heterogeneity of materials. During the passage of an acoustic wave through the heterogeneous material, it is interact with various theaters of the structure. This causes the changes in characteristics of acoustic wave itself, such as absorption, scattering, speed, amplitude, frequency, and accordingly affect the dissemination of acoustic fields. It should be noted that when an acoustic wave passes through the heterogeneous medium, it is modulated both in terms of frequency and amplitude, which leads to its significant change. The wave is broken into a number of harmonic components that disseminate with different speeds and different directions and contains information about the theaters of the structure at different scale levels. Using this phenomenon as a principle of operation of elements of information and measuring systems is largely limited due to the complexity of the analysis of such acoustic transformations. Let's move on to the consideration of thermal processes in non-metallic heterogeneous materials under vibrational influence on them. Anomalies of the temperature fields on thermograms obtained with the help of infrared technology devices may indicate the evidence of artifacts in the extent of the materials of the products under investigation. Here the main informative parameters are the temperature contrast between damaged and damage-free zones in the optimal observation time. Of the interest are the mathematical description of this process. Most of the previously considered works were solved in such formulation that the physical and mechanical characteristics of the material were considered independent of temperature, and they do not take into account the heterogeneity of the researched medium. However, for a comprehensive analysis of the strength characteristics, it is necessary to take into account coupling the thermoelastic fields. It is necessary to simultaneously determine the temperature and deformation fields. Let us consider the transversal isotropic space, inside on which, on a random piecewise continuous surface, there are damage of any nature, for instance, cracks, delaminations, or non-exfoliated inclusions. Components of stress and displacements are described by equation 1, and conditions of equilibrium are described by equation 3, and the head by equation 4. Unlike the classical head conduction equation, equation 4 contains terms that connect the temperature growth with the rate of change in the size of the deformable body. To formulate varieties of the surface omega, where interruption of all vector components are possible, we enter a local coordinate system at each point omega, like you can see in this slide. To do this, at each point of the surface we made triangular plate P and a perpendicular vector n to it. We take another axis, M and S, modeling normally in the plane P, so that after rotating the axis, the directions of the axis and N and S would be the same as the direction of the axis Z, X and Y, respectively. In this coordinate system, stress and displacement will be denoted as follows, like you can see in this slide. The point plus is on the perpendicular side N, and the point minus is on the contrary side. To be specific, on the omega, we will guess that the next jumps are known like equation 5. The temperature conditions on the defect express the conditions of non-ideal thermal contact between the surface of the defect and physically the resistance that the defect provides to the propagation of heat. These conditions for flat crack lying in the plane XOY have the form equation 6. The non-local theory of thermospring has a significant impact on all parameters. Most of the examined works were developed in such a setting if the physical and mechanical characteristics of the material were taken into account such that they did not depend on the temperature. Nevertheless, for the comprehensive analysis of the characteristics of materials, it is necessary to ensure the connection of thermospring fields, so that it is necessary to simultaneously measure the temperature and deformation fields. The article deals with the transversal isotropic space, inside which structural defects of any nature are located on an arbitrary piecewise continuous surface. The mathematical model of thermometrical process in non-metallic heterogeneous materials, while their defect is copied by the acoustic infrared thermometric method, was developed, which is distinguished by the fact that it is considering the connectivity of fields of mechanical and thermal nature, taking into account the heterogeneity of the material structure. It is possible to minimize the problem of solving a system of singular integral equations and obtain the allocation of temperature fields in the vicinity of structural defects of, for instance, cracks and delamination in non-metallic heterogeneous materials. The following works of the authors will be devoted to this issue. When we consider an object made of non-metallic heterogeneous materials in terms of meteorological support of its quality, then it can be interpreted as complex. When analyzing the physical and mechanical characteristic of material, the number of parameters that are taken into account when creating a model mapping is increased by selecting structural levels. A non-metallic heterogeneous materials in our work is presented in the form of transversality isotropic space, inside which, on a random piecewise continuous surface, defects of any nature are located. To formulate the conditions of the surface omega under which discontinuous of all components of vectors are possible, it was proposed to introduce a local coordinate system at each point of the surface omega. The temperature conditions of a flat crack are recorded, which express the condition of non-ideal thermal contact between the surface of defect and physically the resistance that the defect provides to the propagation of heat. Thank you for your attention.
Please start. Please start, Slavomir. Slavomir, you can start.
Віталію, ти мене чуєш?
Я вас чую. Slavomir, please start session.
Okay. So, thank you very much for all of the presentations. It makes me impressive about how actual and how well prepared were the papers, if you include the situation in which they are developed. So let me do this way. The first presented paper was the application of the dynamic programming method in process of measurement problems when accessing interoperability. It's very interesting from my point of view because it is very next to the idea of the systemic view of an organization and processes which are involved in this. The authors indicate or identified the lack of unified approach to creating the various complex organizational and technical system, and they propose some mathematical modeling approach which is used on differential quality sets and make some sensitivity analysis to prove the way how they trying to deal with this problem. So of course, my first question which crossed my mind during this presentation was, okay, I'm involved now in some projects which are about condition-based maintenance systems. And one of the idea is to create some uniform approach in terms of describing the production system. Do we consider your approach and your results as universal from this point of view? Can we use this not only in quality but also and interoperability, but also in the maintenance, data-based maintenance systems?
Unfortunately, there are no speakers of this presentation, but thank you for your explanation and your question. I think they will think about your question after watching.
Okay, so let's make the next step. Due to the presentation order, we had ability to see the presentation on monitoring the accuracy of manufacturing elements of the end distribution system of a hydraulic motor planetary time. That's a very detailed problem, but it was the identification of the problem, as far as I can recognize from the presentation, is very well grounded in the requirements, actual requirements of the industry. So the question is, what are the perspectives of implement these results of research work?
I'm afraid the same situation, there is no speaker.
Okay, so after all, it is impressive and very interesting results. So I think they are almost ready to implement, I think, in this stage. The fifth article which was presented was that's another case how science can be involved in the current issues of the society. Supplying with the fresh water Ukrainian society is one of the most challenging, I think, issues nowadays. So it is another case when the authors are very close to the or very next to the real problems and issues which arouse in industry practice. What is interesting is that the results of analysis which were presented here are deal not only with the technological problems but also using the quality method and techniques like FMAR or risk management. The authors give the final organizational recommendations. So that's very complex results. We have the authors online.
It's a pity to say, but no authors from Odessa, unfortunately, because due to electricity problems.
Okay, so that's the same impression that as previously. We have very interesting and very practical results for the industry. The first presentation was about improving the quality of emotion dispersion in the pulsation homogenizer using computer simulation. And what the thing which is very interesting in the research methods and design of experiments, numerical experiments, which were performed to solve the problem, is that authors use the complex approach, including all of the elements of computer integrated design and engineering of the products. And that's very powerful presentation, what we can achieve using in the process of designing or improving the concept, develop whatever in very early stages in process of improving. We can use a very complex simulation methods to find the solution. After all, there is a new technology which is involved in construction of homogenizer using pulsating vibration of the shock piston. So that's a very complex presentation, including various aspects of the industrial processes, as well as computer simulation and modeling and simulation. So have we authors of online? The same story, Vitaly, I think.
Yeah.
Okay, that's a very pity. And finally, the fifth presentation, which is titled Simulation on Processing Composite Materials Under Thermometrical Control, Taking into Account Heterogeneity. That's a very actual idea to include in the manufacturing processes non-destructive or even non-contact or contactless method. I think without breaking a flow of the process, you can do the inspection. For instance, you can do the visual inspection using some quality aspects of research or analyzing the product, but also the idea of using, as in this case, active thermal control for analyzing the structure of the material, which is obtained in the process of creating non-metallic heterogeneous structures, is very promising and up to date. So that's something which is very actual when we are using different materials by design. I think the materials by design. So the idea is not to use the classical set of the materials and after that trying to fill the requirements of the construction. Nowadays, we are starting with designing the materials too, not only the construction itself. So there is a very promising and very interesting approach, specifically because it is included, the research included a very advanced mathematical modeling of the process. So the results are, I think, applicable for the industry if only probably we find some possibilities to create the demonstrator of the technology, and after that we can introduce it to the industry. So we have the authors, or we have the same situation?
The same situation.
Okay.
So, maybe it's possible to ask Volodymyr Konogi.
So maybe let's collect some questions from the audience. I encourage you, and we give those questions to the authors, because as you probably appreciate it very much, every conference is the opportunity to verify in discussion our ideas. So it's very important. Please, welcome, sir.
Okay, it's question for Volodymyr. In this work, author use acoustic infrared thermal method. I don't understand what is possible. We study and see acoustic signal, infrared signal, or thermal signal. It not acoustic signal is in one part of way, infrared in infrared. It's not the same region. I want to understand what method use these authors. No, okay. No.
I think the authors will consider about these questions and will improve the future research.
Yes. Thank you very much.
Any other questions to presentations presented in this session? No. Thank you very much to Dr. Sławomir Lushinsky for taking care about this session. However, we have a recording on the YouTube, so the authors later can watch these comments, questions, and consider them in further research. Thank you very much, Sławomir, for being
Thank you very much for inviting me. Thank you for your presence here, specifically those which I have occasion to meet in the past years, but all of you are close to my heart. In last couple of years, that's the pity that we still have no ability to meet together, but I think it will be soon. Congratulations for the continuity of the conference. It's a big effort, not only the technological, but also the question of providing the research and the results of the research in those heavy times is also the kind of the heroism, and I admire it very much. Thank you very much, colleagues and friends.
Thank you very much. Dear participants, just a reminder, in 15 minutes we will start the closing ceremony. You can stay here in Google Meet or you can switch to YouTube, it's up to you. So
okay, I will be in the Google Meet, of course.
Okay, thank you. In 1:25 we will start closing ceremony.
So I'm 6 minutes ahead of.
Dear participants, it is a pity to say that the sixth InterPartner conference has come to a finish. In my opinion, this edition is suffering despite the hybrid mode and current situation in Ukraine. InterPartner conference series was organized by Odessa Polytechnic National University, National Technical University Kharkiv Polytechnic Institute, Sumy State University, and the International Association for Technological Development and Innovations. Among our partners are Poznan University of Technology, Springer Nature, Syndicate, and the International Innovation Foundation. The conference included 2 keynote speeches and 10 sessions. 73 presentations were made, and more than 300 participants from 16 countries joined us in a hybrid mode. We were happy to work for you during the 4 days. The full text papers will be published in the book series Lecture Notes in Mechanical Engineering titled Advanced Manufacturing Processes 6, Selected Papers from the 6th Grabchenko's International Conference on Advanced Manufacturing Process. The expected date of publication is December 2024. Thank you very much to the editors for their efforts and support in bringing this publication to life. I would like to express our heartfelt gratitude for the invaluable contribution to our session chairs during the conference. Your expertise, professionalism, and dedication ensured the session ran smoothly, providing an engaging platform for insightful discussions. It is a true honor to work alongside the remarkable InterPartner team. Your dedication, professionalism, and commitment have made it possible to deliver such a successful event on time. I sincerely appreciate the effort each of you has put in. Together, we have created an environment that fosters exchange and innovation. Thank you for making this conference not only possible but also exceptional. Let me share the information from our partners with you. The SME 2025 conference will take place in Portugal next year. Don't miss the deadline for paper submission, which is scheduled for October 15. Please note the special offer for scientists affiliated with Ukrainian institutions. The Journal of Mechanical Manufacturing Engineering offers to publish an extended version of your paper, free of charge publication of papers submitted in 2024. Special issue innovations in design, simulation, and manufacturing of production systems provides discount for papers accepted for publication. The journal Assembly Techniques and Technologies also provides fast-track publication of your extended papers. After numerous discussions, we decided to organize the InterPartner conference series outside of Ukraine. We have received an offer from the Georgian Technical University to hold InterPartner 2025 in Georgia. Recently, it has been 100 years since the birth of the outstanding scientist in the field of mechanical engineering, long-term rector of the Georgian Polytechnical Institute, Teimuras Nikolaevich Laladze. It is proposed to dedicate this conference to his memory. Thus, as everything can be properly organized with the help of Georgian colleagues, InterPartner 2025 will be held in Tbilisi on approximately October 7 to 10, 2025. Georgia is located at the crossroads of Eastern Europe and Western Asia. It is renowned for its warm and generous hospitality, where visitors are treated like family and welcomed with open arms. Georgia is a convenient destination. Daily flights from Europe connect Tbilisi with the rest of the world. Tbilisi has a unique atmosphere. It is a capital and a city where ancient traditions meet modern aspirations. Please note important days. The submission system will be open this December and accept your submissions till February 16. Thank you very much for your participation and welcome to InterPartner 2025 in Georgia. Thank you very much. Slava Mir.
Looks impressive. I should take a vacation time for the next year. Yes.